The first section in our matrix unit is just the very basics introduction of addition and subtraction. So first, when you're determining the dimensions of a matrix, what you want to do is you want to go rows by columns. So what I mean by that is identifying our rows and our columns. So if I'm looking at rows, rows go across. So 1, 2, 3, and 4. This would be row 1. And so on and so forth. Our columns, just like on a house or a building, go up and down. So 1, 2, 3, 4, and 5. This is our first column, our second column, so on and so forth. So when you label it, you say rows by columns. Well, the rows, there's 4 of them, and the columns, there's 5 of them. So it's a 4 by 5. Now for the basic operations of addition and subtraction. In order to add or subtract something, the matrices must be identical. So if you look at them and they're not exactly the same, then you can't put them together. Okay, in this case, all of ours are. The first one, I'm going to say, okay, this one matches up with that one, the top left in both. So my answer matrix is going to be exactly like the one that I just did. So I have 3 plus 0, which is 3. Okay, so then I jump across to the next things that are alike. So I go to my top right. So 6 and negative 1 gives me 5. Okay, so then I start moving down. Negative 1 and 6 gives me 5. Negative 3 and 0 is negative 3. Negative 5 and positive 2 is negative 3. And negative 1 and 3 gives me 2. And that's your answer matrix. It should look just like that. It should be identical to the other two the other two in the equation. Okay, number 2 on this looks a little bit different. It's also subtraction. So what I would do first is I would take this and distribute it to the entire second matrix. So it's going to be a negative 6, positive, positive, negative, negative, positive. So what that does is it turns it to a plus sign in the middle so that you don't have to worry about remembering to do that every single time. So my top left in both go together. So negative 5 and negative 6 is negative 11. Then I move across to the next one. In the top middle for both, 2 plus 5 gives me 7. Top right. Negative 2 and a positive 6 gives me 4. Move down to my bottom row, 3. In the middle, I have negative 2 and negative 3, which is negative 5. And then the last one is 0 plus 3, which gives me 3. And just remember to put your answer into a matrix. Okay, number 3 starts our scalar multiplication. All that it means, it's pretty much like distributive property. So you're going to take this number that's on the outside and distribute it to absolutely everything that's inside of here. Okay, so as you're doing that, your matrix is going to look the same in the end. So you have negative 25, negative 30, positive 20, negative 20, positive 10, and positive 5. And just put your final answer in a matrix. Same thing for number 4. You're distributing this to absolutely everything that's inside of it. So I have a positive 15, 0, 0, and a negative 25, putting it inside of a matrix to make it my final answer. Okay, so now to more complex when you're adding some variables into this. This doesn't necessarily make it any harder, it's just a little bit harder to look at. So with this, you can only combine like terms. And if they're not the same, just put them next to each other. So for example, in the first one, the matrices look the same because they're both a 2 by 2. Okay, so I have 2 rows, 2 columns, 2 rows, 2 columns. But when I look at my top left on both of those, they're not like terms. They kind of seem like terms because they both have a 4, but one is a 4n and one is just a 4. So how I'm going to write that is negative 4n, my sign in the middle is plus 4. Okay, so then I move over to the right in both. Again, those aren't the same as each other. So I'm going to go ahead and write those as n plus m minus 5. Go down to the bottom. Again, they're not the same. One is n and one is m. So negative 2n plus 3m. And finally, the bottom right, well, that 0, I don't even need to worry about putting it anywhere, so I just get negative 4n. Put it inside a matrix so I know that that's my final answer. So the same thing's going to hold true with scalar multiplication for this. You're going to distribute to everything, but remember that when we multiply things, we can multiply things that aren't alike. Okay, so what I mean by that is the negative 3 and the negative 2 multiply together to give me 6. And then the x and the y don't multiply together, but they just sit there next to each other, multiplied, not added or subtracted. When I take it out to the right-hand side, it's a negative 3 and a negative 1, so I get a positive 3. Well, y times y is y squared. Moving down to the bottom row, I have negative 3 and negative 4, which gives me a positive 12. Y times y is y squared. And then the last one is negative 3 times negative 3, which is positive 9. And then y times x gives me yx. Okay, so that's your first page of this. A couple more examples on the next page here. When we're putting these together, I have 1, 2, 3 parts here, 1, 2, 3 parts there. The one thing that you do need to remember is that this is a subtraction sign. So this becomes negative y, positive 2, and positive 3x. So when I'm putting those together, I'm looking at the first one here, and the first one here. So I don't have any like terms in that, so I'm just going to write it as negative x minus 1 minus y. You could have also written it as negative x, negative y, negative 1. You can put them in any order that you want to. Okay, so then the second one that we're looking at with both of these, yes, they both have a 2, but one is 2x and one is just a 2. So my answer to this one is going to be negative 2x plus 2. And then the third one in each is negative 5y and positive 3x. So those also cannot go together. So I have negative 5y plus 3x. Put my answer inside a matrix to make it my official answer. Okay, so then the last one is pretty easy. It's just set up a little bit differently. It's up and down, which I think makes it easier to look at. So I'm going to go straight across the top row here. So I don't have any like terms, so I can just say z minus 5 minus 3y. My second row, no like terms again. Negative 6 plus 3z. Third row, I do have like terms in this one. I have numbers. So the numbers go together. I get negative 1 and a positive 5 gives me 4. Then the negative 6z and the positive z gives me a negative 5z. And my last one has y's and x's, so I just say 3y plus 4z. My final answer has to be inside of a matrix. Okay, so now to the story problem part that's a lot like the assignment that you're getting added to. The National League for Baseball in the Central Division has Cubs, Cardinals, Pirates, Brewers, and Reds. Dating back 3 years, here are the win totals for them. Okay, so we're going to take this and we're going to make a matrix out of it. We could start by making a table if we wanted to. If you're doing it on a computer, you may want to make a table to begin with and then turn it into a matrix, but we're just going to go with a matrix to begin with. What I would do is start by labeling. So we have Cubs, Cards, Pirates, Brewers, and the Reds. Okay, so then the years that we have are 2016, 2015, and 2014. So now I can just take the data from each and put it into it. They're all in a different order, so I have to be sure that I am correctly organizing them. So I went in the order of the first one. So in 2016, 103 wins, 86 for the Cards, 78 for the Pirates, 73 for the Brewers, and 68. In 2015, we start with the Cardinals, so make sure you put this in the right spot. Cardinals had 100, the Pirates had 98, the Cubs had 97, the Brewers had 68, and the Reds had 64. Then 2014, the Cards led with 90, the Pirates 88, the Brewers 82, the Reds 76, and the Cubs 73. Okay, making it a matrix. So then it wants a total matrix. So in order to get a total matrix, well, all we're going to do is add them together. Okay, so all of those together is going to give me 273 for the Cubs. 276 for the Cardinals. Pirates are 264. The Brewers are 223. And the Reds are 212. Okay, so if the question was asking you what the data was telling you, it would be that overall the Cardinals had the best winning record, and the worst winning record would be the Reds. Okay.